All right, this is 6.1 exponential growth and decay. This is our last video, video number 3. In this video, we're going to be finding the balance of an account. So we're going to start using a compound interest formula. So that's our core concept for this one. Okay, so if we have an initial principal, which means the starting amount, okay, if we'd like deposit money, that's the amount, okay, and that's capital P. It's deposited into an account that pays an interest at a rate of R. And now, you might be given the rate as a percent, but you have to change it to a decimal. It's compounded n times per year, and the amount A is in the account is the amount of the account after T years. Okay, so this is the compound interest formula. Kind of an important formula. It's like the formula your banks use, your credit cards use. Okay, this is a formula that we use in life. So let's move this up. I want to be able to at least see that formula, and we're going to find the balance in the account. So you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. So what I like to do with formulas like this that have lots of letters is I start from the left and work my way over, and I write all the letters down. So I have capital A, I have capital P, I have a lowercase r, a lowercase n, I have n again, and then I have a t. So I have 5 variables in this equation. Okay? A is the amount after so many years. P is the starting amount, the initial, okay, it's the principal. Rate, number, this is an N, so number of times it compounds, and T is for time, which is years, okay? So I deposit $9,000, so that's what I'm starting with, so I'm going to put that under my principal. It pays 1.46% annual interest. But I have to change that to a decimal, and you do that by moving the decimal 2 places to the left. So you go whoop, whoop. So obviously a 0 is going to be there. So my R is 0.0146. Find the balance after 3 years, so that's my time. And it's compounded quarterly. Okay, so when we figure out N, it's how many times in 1 year does that compound. And quarterly, you can just think of quarters. There's 4 quarters in a dollar, so that would be 4. Okay? So one thing before we even move any farther is you're going to want to know what all of these compounds are. Okay? So there's many of them. So before we even start, you might want to list somewhere if what n is going to be when, say, it compounds. It might say daily. Well, there's 365 days in a year, so n would be 365. If it says quarterly, that'd be 4. I feel like I spelled that wrong, but and then there could be monthly. Well, there's 12 months in a year. Could be weekly. Well, there's 52 weeks in a year. And it might say yearly. Well, there's only 1 year in a year, okay? So these are the common values for n. So you might want to write these somewhere in your notes so that way you have them. All right, but let's go back to our problem. Now I'm going to plug in what I know into my formula. I don't know A, so I'm going to leave A. P was 9,000. 1 plus R, which we said was 0.0146, over N, which is 4. And the power is N times T, so 4 times 3. All right, now I like to simplify this a little bit before I start plugging things in my calculator, just so you don't make little mistakes. You can leave this like this. Later, when we start solving for something different, you will want to go ahead and simplify it, but we can go ahead and leave this. But I do want to do the 4 times 3, and we know 4 times 3 is 12. So my power is actually 12. And I'm just going to take my calculator. I'm going to go to my main screen here. And I'm going to type it in. 9,000 parenthesis 1 plus 0.0146 divided by 4. I just typed all that in. End parenthesis, and it's to the power of 12. Enter. And it gives me the value, whoops, you're getting lots of glare there, sorry. Well, it gives me the value of A being 9402.21. We are dealing with money, so you give me 2 decimal places. And I should have a money sign in front, and that is the amount in the account after 3 years. You see why saving money is so important? Okay, so now go to your practice and do the last 2 problems, numbers 37 and 38. Get it submitted into Big Ideas, and then submit your screenshot into Canvas.